Hello guys, welcome back to our channel, and in this particular paper we are looking at June 2021 correction, ATC technical. Please don't forget to subscribe and to leave your comments. Stay tuned. Alright, so the first question reads: a polynomial function p is defined by p of x equals x cubed plus ax squared plus bx plus 6. Given that x plus 2 and x minus 3 are factors of p of x, find the values of a and b. Find the values of a and b. Now, since we know that x plus 2 and x minus 3 are factors, it means that if we equate x plus 2 to 0, which we are going to have minus 2, p of minus 2 should normally give us 0 because it is a factor, right? And equally, p of plus 3 will also give us 0. So that's the idea we are going to use. So from this, we have p of minus 2 is equal to 0, giving us minus 8 plus 4a minus 2b plus 6 to be equal to 0. And this will give us the first equation to be 2a minus b to be equal to 1. Now for the second factor, we equally know that p of 3 should be equal to 0. So p of 3 equals 0 implies 27. That's substituting 3 here. We will have 3 cubed, which is 27, plus a into 3 squared, which is 9a, plus 3b plus 6. That should be equal to 0. And this gives us another equation, 3a plus b to be equal to minus 11. To be equal to minus 11. So solving these simultaneous equations, we will have a to be equal to minus 2, and we will have b to be equal to minus 5. Okay, we have b to be equal to minus 5. Okay, that's good. Now the second passage that we should, with these values of a and b obtained above, write out p of x completely, expressing p of x as a product of three linear factors. Three linear factors. Okay, so in this case, since x plus 2 and x minus 3 are factors, means that one factor is left, right? And by testing, we know that that factor should be x minus 1. So we can do long division. We can do some sort of long division like this, and these are the factors that we will have. The remaining factor will be x minus 1, which we can now place here. And the last part says we should solve the equation p of x equals 0. P of x equals 0. Since we already have all these linear factors, a linear factor means that the highest power for each of the factors should be 1. So we are going to just equate all of these to 0. P of x equals 0 implies x minus 1 equals 0, or x minus 3 equals 0, or x plus 2 is equal to 0. And x will be equal to 1, or x equals 3, or x equals minus 2. Okay, so that's it. That's it. Yeah, you can leave your comments. This video is live. You can leave your comments. Now the second question. So for the second question, we have deduce in R the roots of this solution. So if you look at this equation very well, we will see that it is just the same as the previous equation, that they have just done some few adjustments. So this one can be written as, we factor out these two, we have 6 minus 5 ln x minus 2 into ln x squared plus ln x cubed should be equal to 0. So this is identical to the other equation, and since we are to deduce the roots, they have just replaced all of these x in the previous equation by ln x. Here we had 6 minus 5 ln minus 5x minus 2x squared plus x cubed. So they have replaced x by ln x. So the root I had for the previous equation, that is deduction, the roots were 1, 3, and minus 2. So if I solve this equation, my roots will be ln x equals 1, or ln x equals 3, or ln x equals minus 2. So from here, x will be equal to e. You convert from logarithmic to exponential form. So x will be equal to e, that is e to the power 1, which is e. And for ln x equals 3, we will have x to be equal to e to the power 3. For this last one, there is no solution because the ln of a number cannot be equal to a negative. The ln of any number cannot be equal to that. Okay, so for this last one, we have ln x equals negative 2. So from here, we will have x to be equal to e to the power negative 2. That is 1 over e squared. So for this last one, we will have 1 over e squared. 1 over e squared. Okay, I cannot put it down because this is locked a bit. So let me see. So here we'll have the last one will be x is equal to e to the power negative 2. Okay, so these are the roots of this equation. Now the third one says e to the power 3x plus 6 is equal to 2e squared, 2e to the power 2x plus 5e to the power x. So we just need to rearrange this one. If you rearrange, we are going to have the previous form that we had. And from there, our e of x will be equal to this root we are still deducing. So e to the power x will be equal to 1, or e to the power x will be equal to 3, or e to the power x will be equal to negative 2. So from here, x will be equal to 0. We just take ln on both sides here. We will have x equal to 0. With this one, we will have x equal to ln 3. So with this third one, e to the power any number cannot be equal to negative. E to the power any number is always positive. So here we have just two roots. We have x equals 0 or x equals ln 3. Guys, please don't forget to subscribe to this video and leave your comments below. Are there some questions, some past papers you'd like us to answer? Do you want to have more information? You can visit us at www.gcemathspanel.blogspot.com, or you go to gcepreps.blogspot.com and you will still meet us there. Don't forget to share this video with your friends, and we have these corrections on Sundays, so you can always check on our channel live, GCE Maths Panel Online, and you have more information. Now, the second question is f of x is equal to 2x minus 1, all that on x plus 3 into x minus 1. Okay, so this is what we have to express this in partial fractions. To express this in partial fractions, so we have to use the form 2x minus 1 over x plus 3 x minus 1 should be identical to p over x plus 3 plus q over x minus 1. Okay, so from this point, to multiply all through by the denominator on the left hand side, we'll be left with 2x minus 1 to be identical to p into x minus 1 plus q into x plus 3. Now at this point, when x is equal to 1, you substitute 1 here, you have 2 times 1 minus 1, that will give us 1. So we'll have 1 on the left hand side. On the right hand side, substituting 1 here, this term will cancel out. We'll be left just with q into 1 plus 3. So we'll have 1 is equal to 4q, and q is equal to 1/4. Now equally, now when x is equal to 3, x equals 3, what happens? We will have 2 times 3 is 6, which is 2 times 3. We have 6. So 6 minus 1 will give us 5. That's on the left hand side. 2 times 3 is 6 minus 1, that gives us 5 on the left hand side. And then on the right hand side, we will have, if this is equal to minus 3 rather, minus 3, this minus 3 here, minus 3. So we have 2 times minus 3, which is minus 6 minus 1, minus 7. So we'll have minus 7 on the left hand side. On the right hand side, this term will, this first term will not be there. and we'll be left now with minus 3 minus 1, which is minus 4p. So this will give us minus 7, this minus 7, to be equal to minus 4p, and from here p will be equal to 7 on 4. So the next point, this will now give us the values of p and q. Already have them, so we'll have 7 on 4 over x plus 3 plus 1 over 4, all that on x minus 1. Another student may equally decide to write this as follows. You can write it as 7 all this over 4 into what? Into x plus 3 plus, and you do the same the other one, right? So now plus what number here? So we are going to have 1 as a numerator, all this on 4 as a denominator, into x minus 1. X minus 1. So you can equally write it like this. It will be okay. You can equally write it like that. Alright. Now the next one wants us to find the integral of f of x dx. To find the integral of f of x dx. So to find this integral, we already have this function expressed in partial fractions. So it will be the integral of 7 on 4 dx on x plus 3 plus the integral of 1/4 on x minus 1 dx. We can bring out this 7 on 4 and 1/4 like this. We'll have 7 on 4 into the integral of that. And the same thing with the second term. Now, when you look at this type of integrals, to integrate this, we have, if you differentiate this denominator x plus 3, you will have the numerator, right? So just take the ln of the absolute value of the denominator. The same here, if you differentiate x minus 1, you will have the numerator, which is 1. So equally take the ln of the absolute value of the denominator. So this will give us 7 on 4 ln absolute value of x plus 3 plus 1 on 4 ln absolute value of x minus 1 plus k. So this is the integral, where k here is the constant of integration. Alright guys, please don't forget to subscribe and to leave your comments. And that is it. Let's take the next part of it. Okay, now let's calculate the mean value of g of x equals cos x on the interval from 0 to pi on 2. Okay, so let us do it here. How do we calculate the mean of a function? The mean of a function is defined by the mean, let us call this function g, will be equal to 1 all over the upper limit minus lower limit times the integral from lower to upper limit of g of x dx. In this question, our a is 0 and our b is pi on 2. Our g of x is cos x. So this will give us the integral of 1 over pi on 2 minus 0 from 0 to pi on 2 of cos x dx. And what is the integral of cos x? We know that when you differentiate sine, you have cos. So when you integrate cos, you have sine. So this is our integral from 0 to pi on 2. So we have sine pi on 2 is 1 and sine 0 is 0. So we have 2 on pi into 1 minus 0, which is just 1 times 2 on pi. So this is the mean value of this function. Please, as you are watching this video, don't forget to share this link with other friends and to subscribe. It's very important that you subscribe and you click on the notifications. Leave your comments so that we know of any other paper that you would like us to put online. As many comments as possible, or some questions you would like us to solve, leave them and follow us on Sundays as we will be broadcasting live, preparing you for the GCE. If you need personal preparations, you can equally join us on the GCE math panel.blogspot.com, or you can leave us a WhatsApp message from the group at gcepreps.blogspot.com. Now, question 3 of June 2021 paper 2 reads, ATC, evaluate p equals 49 to the power minus 3 on 2 times 81 to the power a half, or that on 25 to the power minus 3 on 2. So to evaluate this, we just need to, and they want us to leave our answer as a fraction, very important. So 49 to the power minus 3 on 2 is the same as 7 to the power 2, further raised to the power minus 3 on 2 times 9 to the power 2, further raised to the power a half, and all that on 25 to the power, which is 5 to the power 2, further raised to the power minus 3 on 2. So simplifying this, these 2 cancel out with this 2. We'll be left with 7 to the power minus 3. This other one will cancel out with this one here, this 2. We'll just be left with 9. Over the denominator, these 2 cancel out with this 2. We'll be left with 5 to the power minus 3. Now from the laws of indices, 7 to the power minus 3 is the same as 1 over 7 to the power 3. So this, and the same too with this denominator, which is 5 to the power minus 3. We can make it to now be the numerator by changing the sign of the power. So simplifying this will give us 5 to the power 3, which is 125 times 9. And the same with the denominator, 7 to the power 3 is 343. So we have left our answer as a fraction. Okay. Now the B part of this question, you are given the function f of x equals 4 sine x minus 3 cos x. And they want us to express f of x in the form r sine x minus alpha, where r is greater than 0. And alpha is an acute angle. I'm giving the values of r and alpha. So what we'll start with in this question is, we'll start by looking at this r sine x minus alpha. We'll expand it. So expanding this will give us r sine x minus alpha will be equal to r sine x cos alpha minus r cos x sine alpha. Now we equate the terms, compare the terms on both sides. So this is also the same like this 4 sine x minus 3 cos x, right? So equating coefficients, I have sine here and I also have sine here. So this means that r sine x cos alpha should be equal to 4 sine x. And the same with this other one here. I have cos x here and I also have cos x here. So minus r cos x sine alpha should be equal to minus 3 cos x. So when you equate coefficients, this is what we will be left with at the end. We'll have r cos alpha to be equal to 4 and r sine alpha to be equal to 3. From here you can find the value of r. R will just be equal to 4 squared plus 3 squared, the root of that, which is the root of 25, and that gives us 5. Now if we divide r sine alpha by r cos alpha, we will have tan alpha to be equal to 3 on 4. So we divide this equation by this other one. We will have r sine alpha over r cos alpha, that is tan alpha, and 3 on 4 is 3/4. So if tan alpha is equal to 3 on 4, then alpha will be equal to arc sine 3 on 4, or arc sine 0.75. This will give us 36.9 degrees. Normally, it's always good to work in radians, but if you look at the value of alpha that we have here, it is not an exact angle. So working with radians here will not actually be a very good idea. So you can also work with degrees. Okay, so in this question, we've worked with degrees. So when the question is like this, you should know what to do. Okay. Alright, so now at this point, we have our alpha to be 36.9 degrees and r to be that. Therefore, our f of x can be written as 5 sine x minus 36.9 degrees as the question stipulated. Okay. Now, hence, determine the general solution of this equation f of x equals 5. So from the previous, because they say hence, whenever they say hence, it means you must continue with the last solution that you had. You must continue with the last solution. And from our last solution, f of x is equal to 5 sine alpha into 5 sine x minus 36.9. So we are going to equate this value to 5. Then so that 5 is common on both sides. We'll divide. We'll have sine x minus 36.9 to be equal to 1. But this one is the same as sine 90, right? So from here, or we can take x minus 36 degrees equals sine inverse of 1. You equally arrive at this answer. And whenever you have sine A equals sine B, to get the general solution, this is what we are going to do. We will say A is equal to 180 degrees n plus minus 1 to the power n B. So this angle now that we have on the right hand side, this is the 90 degrees. It takes this position, while we have this x minus 36.9 degrees at this position. So this is the general solution, but we are solving for x. So we completely solve for x now, and we will have x to be equal to that. Okay. So that is what we have. Okay, let us look at the next question. If you're in need of past papers, please go to www.gcemathspanel.blogspot.com. www.gcemathspanel.blogspot.com. Okay. Okay, now we have this function. The graph below is the curve of a numerical function f in an orthogonal reference OIJ. So let's look at this function very well. So looking at this function, this is the y-axis, as you can see, and this is the x-axis. Then we have this line y is equal to 1. This line is the horizontal asymptote, right? And we have this line x is equal to 5, and this one is the vertical asymptote. If you look at this curve, below this vertical asymptote, the curve is decreasing, and even above it, it is decreasing. So above it, it is decreasing from positive infinity right down to 1, this value of y equals 1, and from below this vertical asymptote, it is moving from negative infinity. Okay, in terms of y, it is moving from y down to negative infinity, so it's decreasing. Good. Now state the domain of the definition of this function. So the domain of definition of this function is a set of all real numbers excluding this value of x equals 5. Set of all real numbers excluding 5. So we have from negative infinity to 5 from below, then 5 from above to positive infinity. This is the domain of this function. Then B, write the equation of the vertical and horizontal asymptotes. So as we just mentioned, the vertical asymptote here is a line x equals 5. Note that the vertical asymptote is a line x equals 5, and the horizontal asymptote is the line y equals 1. Okay. So here we have x equals y equals, okay, small correction here. So for the vertical asymptotes, we have y equals 1, y is equal to 1, and for the horizontal, we have x equals 5. Then here they say we should state the intercepts. State the intercepts. So let us look at the intercepts. The intercepts are the points where the curve crosses the coordinate axis. We have this point at -4. Let us call it the point A. So it crosses at when x is equal to -4 and y is 0. They equally cross at this point where x is 0 and y is -1. Let us call it B. So what will be our intercepts? Our intercepts here will be the points A, -4, 0, and B, 0, -1. And D, find the coordinates of the center of symmetry. So for this curve, the center of symmetry should occur where these two lines intersect. This is the center of symmetry, right? And this center of symmetry is given by the vertical asymptote 5 and the horizontal asymptote 1. So this is the center of symmetry for this curve. E, solve in R the inequality or inequation f of x equals 0. F of x, okay, greater than 0. Thank you for correcting. F of x is strictly greater than 0. So they want us to give the range of values of x that satisfy the equation y is greater than 0. So we are just solving for y is greater than 0. Now let's look at this curve. Below this line, below this x-axis, this curve is negative. The value of y is negative above it. And if we look at above it, let me extend this line, you have something like this. So from this point, from this -4, the y values are positive. But -4 from above right down to 5 from below, this curve is having negative y values. So it means that we should leave out this region. This region like this, from -4 to 0 to 5. From x equals -4 to 5, what do we see? We see that in this interval, the values of y are negative. So we just have to consider from negative infinity to negative 4, and the curve again continues to be positive from this point. From negative infinity, that's up here, right? So it is positive. All the values of y are positive right down here. So we have from negative infinity to negative 4. Then the positive part continues from when x is equal to 5 from above to positive infinity. Now they want us to draw the variation table. So the variation table, we have this. So the domain of definition is from negative infinity to 5, where 5 is a vertical asymptote, right? So the vertical asymptote, and to positive infinity. Now in the region from negative infinity to 5, what do we see? The curve is decreasing. So we have this negative here, and equally from above 5, it is still decreasing. We have this other negative here. Then the next thing, as you have seen that it's decreasing, when x is negative infinity, at x equals negative infinity, the value of y is 1. It's around, let me say the point is around here. So y is 1. That's why we have this 1. And then 5 from below, this curve should be at negative infinity. That's why we have negative infinity at this point. Then x, the value of y when x is equal to 5 from above. 5 from above, the curve is at positive infinity. Is positive infinity. Then when x tends to negative infinity, this curve will almost touch this line, y equals 1. So you tend to 1. These are the limits, right? So therefore means that, as you can see, the curve is decreasing at this point. Please don't forget to subscribe to our channel and leave your comments. If there are some papers you'd like us to answer, you leave a comment down, and you can equally send the papers to us on WhatsApp. Join us every Sundays for preparation, and don't forget to share these videos with your friends and to leave your comments. When you subscribe, click on the notifications so that immediately we start class, you are notified. Alright, now question 5. Solve in R the equation t squared minus 3t plus 2 equals 0. T squared minus 3t plus 2 equals 0. So you can solve by factorization. You can solve by using the quadratic formula. You can use another method. Let us solve by factorization. The two factors that we multiply, we will have 2, and when we add, we will have negative 3r. You have minus 1 and minus 2, right? So these are the two factors. At this point, we will have our t minus 2 to be equal to 0, or t minus 1 equals 0. So the values of t are t equals 2 or t equals 1. Okay, t equals 2 or t equal to 1. Okay, now for the sub 2, solve in R the following equations. Solve in R the following equation. So since you already have the value of this first equation, if you look at it very well, it's that this second equation is just the same thing. They have replaced t by log x. You say hence. Hence means we must use the previous answer that we had. So from here, our log x should be equal to t. So log x will be equal to 1, or log x equals 2. We now convert from logarithmic form to exponential form. We will have x to be equal to e to the power 1, which is e, or x equals e to the power 2. So hence this is what we have. And this other third one is the same thing, but we have to first of all understand that we have to multiply all through the equation by e to the power x. When we multiply all through by e to the power x and arrange, we'll have e to the power 2x minus 3e to the power x plus 2 equals 0, which is identical to this first equation, and we can use our hence now. Since the roots here were 2 and 1, therefore the roots of our equation here will be e to the power x equals 1 or e to the power x equals 2. Okay, so this is what we will have. And now you equally have this equation e to the power 2x plus 2 minus 3e to the power x plus 1 plus 2 equals 0. So with this one, they have replaced t by e to the power x plus 1. So that's what they have just done. So this one is the same as e to the power x plus 1 further raised to the power 2 minus 3e to the power x plus 1. So since our roots here were 1 and 2, so e to the power x plus 1 should be equal to the first root, or e to the power x plus 1 should be equal to the second root. So we take ln on both sides. We will have x plus 1 to be equal to ln 1, which is 0, or we will have x plus 1 to be equal to ln 2. From this one, we'll have x to be negative 1, or x here to be equal to ln 2 minus 1. So these are the two roots of these equations. Yeah, this question is actually a nice one. Right, the sum of n terms of a particular sequence is given by Sn equals 17n minus 3n squared. Minus 3n squared. For this paper, go to GCE mathspanel.blogspot.com and you find it there. Now, sub 1, determine an expression for the sum of the first n minus 1 terms of the sequence. So for the sum of the first n minus 1 terms, we will just replace n by n minus 1. Okay? So this will give us the sum of the first n minus 1 terms will just be equal to 17 into n minus 1. So we have 17 to n minus 1 minus 3 into n minus 1. Okay? So we have 17 minus 17n minus 3 into n. Okay, here we have 17 minus 17n minus 17n. So 17 into n minus 1 will give us 17n minus 17 minus 3 into n minus 1 squared is n squared minus 2n plus 1. So when we simplify this, we'll have minus 3n squared. So plus 17n plus 6n will give us, that is minus 3 times minus 2, that's plus 6, will give us 23n minus 17 minus 3 minus 20. So this is what we have, minus 20. So that's this expression for the first n minus 1 terms. Now we have been told that hence or otherwise determine an expression for the fourth term in the series. So the fourth term, the nth term for this type of series that is defined by sum is given by Sn minus Sn minus 1. Okay? So to find the nth term, it will be the sum of the first n terms minus the sum of the first n minus 1 terms. So this will give us, the sum of the first n terms is 17n minus 3n squared. And the sum of the first n minus 1 terms is, as we have above, so minus 3n squared plus 23n minus 20. When we simplify this, we will have 20 minus 6n, where n is an element of n star, just as it was given in the equation above, n star. N star means set of all natural numbers excluding 0. So whenever you see the star, it means exclude 0. Question 6. A geometric progression Vn, where n is an element of n star, is defined such that 2Vn minus 3Vn plus 1 is equal to 0, and V1 equals 2. So V1 equals 2 means the first term is equal to 2. A part of the question says determine the common ratio of Vn. So from this expression here, we can simplify it. We will have 3Vn plus 1 is equal to 2Vn. So we know that to get the common ratio, we just have to look for Vn plus 1 on Vn, right? So we just have Vn plus 1 on Vn should be equal to 2 on 3 here. So this Vn here, this we just divide both sides by Vn and divide both sides again by 3. So our common ratio is equal to 2 on 3. Now, given that Sn is equal to the sum of all of these terms up to Vn, calculate S10 to 4 significant figures. Let's calculate S10. So our S10 will be equal to V1 into 1 minus R to the power 10, all that on 1 minus R. Okay, so what will this give us? This will give us 2 into 1 minus 2 on 3 to the power 10, all that on 1 minus 2 on 3 on 3. So with this, if you further simplify, we'll have 6 into 1 minus 2 on 3 to the power 10. And what will be this value? So on our calculators, if we are to do this, raising this to the power 10, then we will have 2 on 3 to the power 10. So this will give us 2 divided by 3. Let me do it by my own calculator. On 3. So we raise all of this term to the power 10. So when we raise this to the power 10, we will have, this will be equal to, and so we should give our answers to 4 significant figures. So this will be equal to 5.8959. So 896. So the answer will be 5.896 to how many significant figures? To 4 significant figures. So this is what we have for this calculation. Then the deeper says that we evaluate this limit, the limit of Sn as n tends to positive infinity. So we just go to our formula now. N tends to positive infinity, we will have 2 into 1 minus 0. Because as n tends to infinity, what happens? R to the power 10 will be equal to 0. Right? Because we have 2 over 3 to the power infinity. In fact, any number that lies between minus 1 and 1, when you raise that number to the power infinity, what does that give us? That gives us 0. That's why we have 0 at this position. So we'll have 2 into 1 minus 0 on 1 minus 2 on 3, and this gives us 6. So that is why we have 6 here. Okay. Now the next question, we have a circle is given parametrically by the equation x is equal to 4 plus 3 cos theta and y is equal to 3 plus 3 sine theta. Find the Cartesian equation of the circle. So Cartesian equation of the circle is that equation that expresses the circle as x minus a squared plus y minus b squared is equal to r squared. That is the Cartesian equation of a circle. That's what we want us to do. So from here, we'll start by making cos theta the subject of the formula. From here, cos theta will be equal to x minus 4 on 3. Then sin theta the subject of the formula of the second one. Sin theta will be equal to y minus 3 on 3. From trigonometry, we know that cos squared theta plus sin squared theta equals 1. So here, this will imply that these are x minus 4 on 3 squared plus y minus 3 on 3 squared should be equal to 1. That is trigonometry. Now the denominator is 3, or let's say 3 squared. So we multiply all through by 3 squared, and we'll be left with x minus 4 squared plus y minus 3 squared equals 9. So this is the Cartesian equation of this circle. They say hence or otherwise state the center and radius of the circle. So you can use another method to get the center of the circle, but here I'll use the hence. I'll do it directly. So from here, we know that the center of the circle will be the negative of this value. So negative, negative 4, negative of negative 3. Because now the equation of the circle is given as x minus x0. So my x0 here is 4, and y0 is 3. And the radius of the circle is equal to the square root of this number. Because this is equal to r squared. So this is equal to r squared. So therefore my r should be equal to the square root of this 9, which is 3. Now C, draw the circle taking I equals j equals 2 centimeters. And this is very important because they want us to take 2 centimeters to represent 1 unit on both axes. So this is what I have. If you look at this, my diagram, this will be 1, 2, 3, 4, 5, and so on. And equally here I have 1, 2, 3, 4, 5. What have I done? If you look from 0 to 1, this is 2 centimeters. These 2 centimeters represent 1 unit. Then 2 centimeters represent 1 unit. And this is on the J axis. And what about the I axis? On the I axis, I have the same thing. So this is my circle. This is the center. And this center is, from what we have here, the center is 4, 3. And the radius is 3 units. So this is this circle with center 4, 3 and radius 3. And we have taken 2 centimeters to represent 1 unit on both axes. Guys, please don't forget to subscribe and to leave your comments. Immediately you subscribe, click on that bell button that you see. It's called the notifications button, so that whenever we upload a new video or new correction, you are immediately notified. Please don't forget to subscribe, to share our videos, and to leave our comments. That's what is going to motivate us to produce more videos for you. If you need in other subjects, you can equally get videos by going to our blog www.gcemathspanel.blogspot.com. And if you need private preparation for the GCE or to join a WhatsApp group, if you need a free WhatsApp group, you can go to www.gcemathspanel.blogspot.com. You look under GCE past papers if you are O level or A level. From your level, you will see the WhatsApp group link there. You join. If you need a special preparatory class, you can equally contact us on WhatsApp directly, and we'll start immediately. In 4 weeks to 3 months, we prepare you completely for the GCE. Thank you. Don't forget to subscribe. Now, question 8. A linear function p of x equals mx plus n, where m and n are real numbers. And this is a transformation that transforms elements of the set x comprising of 1, 2, 3, 5, 8, 11 to elements in set y, such that p of 5 is 13 and p of 1 is 5. Now they want us to determine p of x. They want us to determine p of x. Okay. Now, from what we have been given here, we see that p of 5 is 13. So that will give us 5m plus n equals 13. So this is my x. I'm replacing this x here by 5, or substituting. This gives me the first equation. This is my equation 1. And second, I've been told that p of 1 is equal to 5. So I'll substitute 1 there also. And I will have m plus n. Alright, not this 5 here. So we equally know that p of 1 now is equal to 5, please. P of 1 is equal to 5. Alright, p of 1 is equal to 5. So this gives me m plus n to be equal to 5. Okay, so m plus n to be equal to 5. So from these two equations now, I'll have, if I say equation, this is equation 2. So if I say equation 1 minus equation 2, this will give us 5m minus m. So we'll have 4m to be equal to 8, and m will be equal to 2. And if you substitute the value of m equals 2, we will have our n to be equal to 3. So it therefore means that our p of x can be written as 2x plus 3. 2x plus 3. Now, they say we should calculate the mean and variance of x. So the mean of x will just be equal to the sum of terms divided by the number of terms that we have. So we have 1 plus 2 plus 3 plus 5 plus 8 plus 11 divided by 6. And that will give us 5. Okay? Because when you add all of this, you have 30 divided by 6, that's 5. And now the variance is the summation of the deviations. That's the summation of the squares of deviations divided by the number of terms. So the variance will be equal to, the first term is 1 minus the mean, so 1 minus 5 squared plus 2 minus 5 squared plus 3 minus 5 squared plus 5 minus 5 squared plus 8 minus 5 squared plus 11 minus 5 squared. Alright, so we have plus here, plus, and the last one plus this. All of that divided by 6, and that will give us 12.33. So that will give us 12.33. Okay, the next part of the equation, we have a random sample of ages of 50 civil engineering and building construction students were recorded as follows. We have their ages in years. 5 of them were 18 years old, 10 of them are 19 years, 15 of them are 20 years, 9 of them are 21, 5 of them are 22, 3 of them are 23, 2 of them are 24, and 1 is 25 years old. They want us to determine the mode and the median. So the mode is the age that has the highest number of students, and that age corresponds to 20. So 20 years is the age that many students have. So most of them are 20 years old because it has 15. This is the highest frequency. So from here our mode is 20. And for the median, since there are 50 students, the median should occur at the middle position. And the middle position is between 25 and 26, because we have 25 to the left and 25 on the other side to the right. So the median is not actually on any student. So we have 25 students on the left, 25 on the right. So like a wall, 25 this one, 25. So the median should be equal to the average of the 25th student. So the 25th plus the age of the 26th divided by what? Divided by 2. So let us look for the age of the 25th students. Let's be adding. We have 5 plus 10, 15. We have not arrived 25. Now 10 plus 15 is 30. It means that the 25th and the 26th students are all here. They are both 20 years old. So we will have 20 plus 20 divided by 2, which is 20. That's why our median here is 20. Or you can write all of these numbers on the line. You have 18, 18, 18, 18, 5 times 19, 10 times 20. And then you now check and see where the 25th age and the 26th age, and then you take the average. And this is what you have. Okay. Now construct a cumulative frequency table for the data above. So cumulative frequency just means just be adding the frequencies, and when you're adding like this, you should arrive, the last frequency should be 50 because they said there were 50 students. So this is my table. You just have to add another table here, but since there is no space, you just copy out the table like this. The cumulative frequency, the first frequency is 5, so we have 5. Now this 5 plus 10 will give us 15. This is the 15 here. Now 15 plus this 15 will give us 30. 30 plus 9 will give us 39. 39 plus 5 will give us 44. 44 plus 3, 47. 47 plus 2, 49. 49 plus 1, 50. So this is the cumulative frequency for the data. Calculate the percentage of the students whose ages are above 20 years old. The percentage. So we just need the number of students who are above 20 years old. Okay. So that will give us 39 plus 44 plus, let me see, those who are above 20, we will just have. Now the number of students who are below 20, or let me say 20 and below, there are 30 students. So if 30 students are 20 and below, how many students are left? We have 20 left, right? So it means that those 20 students are above 20 years. Or we can add those who are above 20. Let's count. We have 9 plus 5, 14. 14 plus 3, 17. 17 plus 2, 19. 19 plus 1, 20. So how many students are above 20 years? There are 20 students. Out of how many? Out of 50 times 100, and that will give us 40%. So 40% of the students are above 20 years old. But you will not have the complete answer here if you leave your answer as 40%. They say if you give your answer to how many decimal places? 1 decimal place. So what will be the final answer? The final answer will be 40. Yes, please. 40 points. 40.1. Thank you so much. 40.1. 0.0%, not 40.1. Alright, so we have 40.0% because if you give an answer to 1 decimal place. So we have 40.0%. Alright, the next question. The next question. Question 9. Solve the set of simultaneous equations. So to solve this equation, you can start by letting x capital X to be equal to what? Small x plus 1 now. Okay, so you can use this method to be equal to small x plus 1. And what will you do with capital Y? You will let capital Y to be equal to y plus 2. Y plus 2. And from here you can solve the equation 2x. So this will give us, for the first equation we'll have 2x minus 3y, that is capital Y, to be equal to minus 2. Okay, and for the second one we'll have capital X plus 2y to be equal to which number? To be equal to 13. Equal to 13. You can solve these equations, or you can solve it directly without saying let this one be equal to that. So here I'll just multiply this equation 2. Let me call this one my equation 2, and this one equation 1. So I'll just multiply equation 2 by 2, and this is the result that I'll have. From here now I have x plus 1. The coefficients of x plus 1, equation 1 and equation 2 are now the same. So I can say equation 2 minus equation 1, right? This is my new equation 2. So equation 2 minus equation 1, what would that give us? Yes, please. So this will give us 4 into y minus 2 minus 3 into y minus 2. So that will give us 7 into y plus 2 to be 26 minus 2, 28. From here, y plus 2 will be equal to 4, and y will be equal to 2. We now substitute this value of y equals 2 in any of the equations. You can substitute in equation 1. So this is that I've substituted at this position. Substitute y equals 2 here, and you solve. You have your x to be equal to 4 when you simplify. Guys, please don't forget to subscribe and to click on the notifications bell so that when we are doing the corrections next Sunday, you are immediately notified when we are live. We will normally be live in the evening, or we can do a premiere. Don't forget to share our videos with your friends. That will be the motivation that you'll be giving to us. Don't forget to leave your comments, and you can equally propose maybe a particular paper or mock that you like us to solve, and we will be at your service. If you're interested in having a copy of this paper, go to www.gcemathspanel.blogspot.com. If you're interested in joining a free WhatsApp group, still go to www.gcemathspanel.blogspot.com and check under past questions. If you're A-level, you find a group under A-level past papers. If you're O-level, you find the group under O-level past papers. You can join from there directly. If you need a private tutor to prepare for the GCE in maybe 4 weeks to 3 months, and you can get to us directly on WhatsApp. Now let's continue with this question. Consider a classroom with dimensions e to the power x meters by e to the power y meters, where x and y are the values obtained above. Recall that our x was 4 and our y was 2. Calculate the exact area of the classroom. So how do we calculate the area of the classroom? Is given by length times width, right? So that will give us the area to be equal to length times width. So that will give us e to the power x times e to the power y. That will give us e to the power x plus y. But our x is 4 and our y is 2. So that gives us e to the power 6, which is equal to 403.4288 square meters. So this is the exact area of the classroom. Now in the sub 2 of the question there, we have been told that how many square tiles of size 30 centimeters want to tile the classroom will be required to completely tile the floor. So let us recall that 30 centimeters, since these units here are in square meters, let us convert these dimensions to meters. So 30 centimeters is 0.3 meters, and a square tile means that the length is equal to the width, right? So what will be the area of one square tile? One square tile, the area will be 0.3 meters times 0.3 meters. That will be equal to 0.09 square meters. So the number of tiles to tile this floor should be equal to the total surface area of the floor, that is 403.4288, divided by the area of one tile. And this will give us 404,483 tiles. because I cannot be talking about and a half tiles, so you round up to the whole nearest whole number. That gives us the number of tiles. Okay, so these are the number of tiles that are required. Then sub 3, if one carton contains 20 tiles, how many cartons of tiles will be required to fill the classroom? So we need number of cartons. We already know that we have a total of 4,483 tiles. So the number of cartons that we need will be equal to this divided by 20. That will give us 224 cartons. That's 224.15. But 0.15 carton, that's approximately 225 cartons now. Yes, as somebody that is doing the job, you have to take 225 cartons. So this is approximately equal to this number. Okay. Now, how much will be paid for all the tiles, given that a carton of tile costs 7,000? So this will be 224.15 times 7,000. Note, at this point, is good. You use this 224.15. You can round up your answer. Okay. Yeah, this is requirements for technical calculations. So this will give us 1,568,889 francs. That's the amount that will be required. Well, normally students that use 225 times 7,000, because the number of cartons is 225 times 7,000, the working is still okay. So this one is more precise. And the last question for the day, find the number of permutations of the letters of the word engineering. The number of permutations is given by n factorial, provided no number repeats. But here we can see E repeating, G repeating, I repeating, and N repeating. And whenever numbers repeat like this, then we'll divide that n factorial by the number of times the number of factorials of each letter repeating. So this will give us, we have 11 factorial on, 3 factorial, 2 factorial, 3 factorial, 2 factorial, 1 factorial. So this gives us 227,200. Why have I divided by all of this? This is because here we have n appearing 11 times. The number of letters here, there are 11 of them, of which we have 3 e's. That's why I have 3 factorials here. We have 2 g's, so 2 factorial. We have 3 n's, so 3 factorial. We have 2 i's divided by 2 factorial, and we have just 1 r, 1 factorial. So that's why this answer is like this. Now solve in the set of natural numbers this equation. We have n factorial on n minus 2 factorial minus 72 equals 0. So I'll just work with this n factorial until I have n minus 2 factorial and I stop. So n factorial is the same as n into n minus 1 into n minus 2 factorial. I'm stopping here now because this n minus 2 factorial cancels out with n minus 2 factorial, and I'll be left with n into n minus 1 minus 72 equals 0. So this gives us n squared minus n minus 72 equals 0. We can factorize or use the quadratic formula. We'll have n equals 9 or n equals negative 8. But what does the equation say? Solve in the set of natural numbers. So the only correct answer is n equals 9, because 9 is an element of the set of natural numbers. The C part, a delegation of 15 students is to be selected from 6 industrial and 6 clothing industry students to represent the school in the competition. This delegation must consist of at least 1 industrial student and 1 clothing industry student. Find the number of ways this delegation of 5 students can be selected. So with this selection, they can decide to select 1 student from industrial and 5 from clothing industry, because the number should always be equal to, alright, the number should always be equal to 5. So select 1 from this department, 4 from the other department, or 2 from this department, 3 from the other, or 3 from this department, 2 from the other, or 4 from this department, 1 from the other. They cannot select all 5 from one department. So this arrangement will be either we have 4 clothing industry, 4 industrial and 1 clothing industry, or we have 3 industrial and 2 clothing industry, or 2 industrial and 3 clothing industry, or 1 industrial and 4 clothing industry. This is where it ends. You cannot go above this. So the numbers always be equal to 5. Now with permutations and combinations and selections, OR means addition. OR is addition. And then AND, this AND here is multiplication. Because you talk about 4 industrial and 1 clothing industry. This means what we will have here times this one. The same thing here. What we will have here times this one. What we will have here times this one. And what we equally have here times the other one there. So in this first case, we talk about 4 industrial students. It means we are selecting 4 from 6. So that's given by 6 combination 4. So we select 4 students from 6. And now it's multiplication. And we select 1 from 6. Because there are 6 clothing industry. So select 1 from 6. Now OR. So plus. We select 3 from 6 industrial students. So 6 combination 3. And that is times now. And 2 from 6. Or we will select 2 from 6 and 3 from 6. Or we select 1 from 6 and 4 from 6. So from here now, what is just left is to simplify. So 6 combination 4, as you know, is given as 6 factorial on what? 6 factorial on 4 factorial 6 minus 2 is 6 minus 4 is 2. So that gives us 6 factorial on this 4 here. Then now 6 minus 4 is 2. So we have 6 factorial on 4 factorial 2 factorial into 6 combination 1 is 6 factorial on 6 minus 1 is 5. So 6 factorial, all that on 1 factorial, this one here, and then 6 minus 1 is 5. Plus, I'll talk about this 2. Don't bother about it. I'll talk about it. Why I've put 2 here. Now plus, this second one is 6 combination 3. That is 6 factorial on 3 factorial, 3 factorial. Then 6 combination 2 is 6 factorial, 2 factorial, 4 factorial. Why have I put these 2 here? If you look at this one, this first one and this last one, they are repeating, right? So this one occurs 2 times. Okay? So that's why I put these 2 here. Instead of writing it 2 times, I've written it once. And equally, this one and this one are the same. You know that A times B is same as B times A. And that's what you have here. 6 combination 3, 6 combination 3, 6 combination 2, 6 combination 2. So that's why you have 2. This one occurs twice, and this other one also occurs twice. So simplifying, this will give us 6 factorial, 6 times 5 times 4 factorial. So that this one will cancel out now with this one. 2 factorial is just 2. So this 2 will cancel out with this 2 here. Then here, times 6 times 5 factorial on 5 factorial, 1 factorial. This 5 factorial cancel out this 5 factorial. 1 factorial is 1. So plus 2 into all of that. So this 6 factorial is as 6 times 5 times 4 times 3 factorial. So that this 3 factorial will cancel out this 3 factorial. This other 3 factorial is 3 times 2, which is 6. So this 3 factorial will cancel out with this 6. And then here we have 4 factorial will cancel out with 4 factorial. And then 2 will cancel out with this. We'll be left with 3. Okay. So we will now be left here with 6 times 5. 30 times 6. So 2. So 2 times 5 which times so 6 times 5 is 30, right? Or 2 times 15, depends on how I cancel it out. And then plus this other one, you have 2 times 5 times 4 is 20. And then times 5 times 3 is 15. So this gives us what value? 15 times 6 just give 118 plus 2 times 20 is 40 times 15 is 600. So 180 plus 600 is equal to 780. Guys, please don't forget to subscribe to our channel and to leave your comments. Immediately subscribe, click on that bell that you see, it's called the notifications bell, so that when we are live broadcasting or we leave any other video to help in your academics, you'll be immediately notified. To support us in our work, please share our videos and click on the like buttons. Share our videos to all WhatsApp groups in you should find yourselves. Share to Facebook groups. And why not discuss about our platform with your friends? To get to us, you can just go to www.gcemathspanel.blogspot.com. You will find our past papers and some corrections. You can equally visit our channel on YouTube, where we have a number of countless lessons just to promote you in your education. For past papers, equally go to our blog, www.gcemathspanel.blogspot.com. If you are interested in helping us with any past paper or corrections or whatever, please send to our WhatsApp number. Please, if you have corrections of past papers in other subjects, please send to us so that we can use those corrections and diffuse them through our channel. Thank you so much for watching. God bless you.